Hello and welcome back for another VMK in the C++ series. In this VMK, I'll be describing the standard template library that I like to use whenever I'm programming anything. The standard template library is really used as a time saver. It's a collection of commonly used functionality that you can use for games, for regular GUI programs, for pretty much anything that you want to create. It'll save you time, and the functionality is actually very helpful whenever you're trying to organize things into containers. The standard template library is really a way to organize your data, and it has a lot of functionality to manipulate the data that you're organizing. So it has ways to sort your data, it has ways to search through your data, it has ways to move your data around in arrays and things like that. So let's go into Visual Studio and I'll demonstrate specifically how to use the vectors, how to use strings, and how to use the maps inside the standard template library. So to begin, let's go and create a new project. It's going to be a Win32 console project, and I'm going to call this STD project. Under Application Settings, we just have console application selected, and this creates our standard main entry point into our program. Now, when using the standard template library, you need to include at the top which kinds of files you'll be using inside of your program. So to start off, I'm going to demonstrate how to use the vector, which is a container that contains an array of items. So to use a vector, you need to go in here and include vector. Notice that there is no .h at the end here. It's just vector in angled brackets. Now, I'm going to create a vector, and the vector belongs to a namespace called STD. So you need to type in STD and then double colon, and here we're typing in vector. And vector is a templated class, which means that you can create this array of items for any kind of type that you like. And you need to specify what type you want as a parameter here inside angled brackets. So let's say I'm going to create an array of integers. So you do something like this, and then the last parameter here, or at least the last thing you type in on this line, is the name of your variable. So I'm going to specify that this is a vector of integers. Now, you may be wondering, why would you want to use STD Vector to store an array of integers when you could achieve the same thing by doing something like this? Integer, let's say I'll call this I array, and then maybe I'll allocate 10 to it. This also is an array of integers, and I've said that this array will contain 10 items. Well, the nice thing about using STD Vector is that I don't need to say exactly how big this container is. The standard template library will keep track of this by itself, and if I need to expand it, it will do that automatically for me, and it actually handles all the memory allocation as well. So anytime that it expands, it will allocate the memory, copy everything over, make more room, and then when I'm done with it, it'll clean everything up nicely. I don't have to worry about any of that extra work myself. So let me demonstrate some of the functionality we have with STD Vector. For instance, I can type in here printf, and let's say we want to know the size of our current array. I'll do %d, and we want to take a look at the size of the vector vint, so I can just type in here dot size. What this is going to do is it's going to return to us the current size of our STD vector. Let's go and build our program and run it by pressing Ctrl F5. And notice it says size and then it says 0 at the end here. I'll put a carriage return to make it a little more obvious. So there we go, we have size and 0. It's currently 0 because we don't have anything stored inside of this array. Well, to place something inside of the array, it's pretty easy. We just type in vint, the name of our variable, and then we use a call called pushback. inside here we specify what value do we want to push back. Well, because we're working with integers, we're going to be pushing back integers. So I'll give some numbers here that I'm going to push back. Let's say we're going to push 34 in, then minus 8, and then let's say 100. After doing all of this, let's go and print out the size again. You notice now the size has changed to 3. So automatically, the standard template library has just enlarged this variable space to contain more room so that I can have all these variables. When I initialized our STD vector up here, I could have said, please allocate a certain amount of memory. And you can do that just by putting in brackets here the size that you would like. If I run this program, notice that initially now it's 10, and when I push 3 more on there, then the size increases to 13. So that's how we can go ahead, create a STD vector, and push stuff onto it. Let me demonstrate some of the other functionality that you have inside STD Vector. There's a flag that you can use that will tell you whether your vector is empty or not. So I'll just create a temporary variable here called as v, and vint.empty. What this is going to do is it's going to return to us a boolean telling us whether our vector is empty or not. And again, I'm going to print to the screen here. Like so. So when I run the program, notice that it says it's not empty now. But if I were to comment these lines of code over here out, then it says the vector is empty because the size is basically 0. And if you go and experiment here, you can take a look inside of all the other functions that we have to work with. We have all these clear, empty, end, erase, front, insert, and all these other ones. So if you just go play around with them, you can sort of get familiar with how these work. And as a matter of fact, a really good resource for anything inside C++ is MSDN. And if you install Visual Studio on your computer, I highly recommend you install the documentation, because documentation talks about pretty much everything that there is with the compiler. So you can get pretty good sample code in here. For instance, if you type in vector, you have your vector class, and then you can go in here, read about vectors, members, and things like that to see basically how this class is working and what kind of functionality you have. And there's a lot of information in here that, well, I'm not going to describe because, well, that would just take too long. All right. Some of the other functionalities that I commonly use with vectors is being able to extract data from an array that I've already pushed data inside of. So for instance, I've pushed in 34, minus 8, and 100. What if I wanted to get these numbers out of the array? The way that I usually do this is creating a for loop. Let me just close this off. It's bothering me. Start it at 0. And then we're going to go I is less than, well, we want to go through the entire size of the array, so we're going to go in like this, size, stepping one at a time through the array. And we want to print these values to the screen, so we can do that just by typing in printf %d. And all the values you can get out of the array just by using square brackets like so. So now notice that, oh, I forgot a carriage return here. So now notice after not empty here, because we've displayed not empty, I display everything that's inside of our array. So we have 34, minus 8, and 100. And if I go in here and add a couple other ones, then you'll be able to pull those out of the array as well. like so. After you've pushed data into the array, you may also want to be able to remove data from the array, and you can use that by using a function called Popback. So if we go vint.popback, what this is going to do is it's going to just remove one item at a time out of the array. So if I call this guy, let's say 3 times, I currently have 1, 2, 3, 4, 5, 6 items in here, and I'll actually display that to the screen. So I'll show you how many I have, then I'll pull 3 of them out, and then I'll show you how many I have afterwards as well. And let's just get rid of this stuff. So we have 0, we put 6 on, and then we've pulled 3 off, so we have 3 left. So that's how you use Popback. You can also, with one function call, clear everything out of the array, and that's just by calling the command clear. And what this is going to do is just destroy everything that was inside of the array. Well, actually, it cleans everything up for you, so you have no memory leaks, and you're basically left with nothing inside of your array. Another common way to go through your array and actually get items out of your array, other than using the for loop the way that I showed you earlier, is by using an iterator. And an iterator is used quite heavily with pointers whenever you're using linked lists and things like that, but you can also use them with vectors as well. So let me demonstrate how to do that. You first have to create your iterator, and when you do create it, you need to specify what kind of iterator you would like. And because I'm going to be iterating through our vector of integers, I need to specify here that I want to create an STD vector of integers, then I put a double colon in here and I type in iterator. So this is going to create an iterator to this kind of data type. Now, when using this iterator, we're going to create a for loop, and we're going to assign the iterator to the very beginning of our array. And the way we can do that is by calling vint.begin. This guy here is going to return to us an iterator to an STD vector of integers. You can see that inside of the highlighted box there. And we want to iterate while we're not equal to vint.end. So we're going to continue going through this iterator until we've basically reached the very end of the array. And every time through, we're going to just iterate once inside of this iterator. Now, instead of doing something like this, where we had inside of our for loop where we were dereferencing using the square brackets, when we're using an iterator, what you do is you want to get the value of our iterator. You would place the iterator beside a star and then put brackets around the whole thing. This basically says get the value of this pointer, which is pointing to an integer which is inside of our STD vector. So we can print this to the screen. %d, carriage return, comma, and then close that off. So there we go. We see that all the values here that I pushed into the array are now displayed to the screen because we're using this iterator to go through the entire array from the beginning all the way to the end, iterating one at a time through the array. We can go through, actually, we don't have to go through one at a time. We could maybe go through 2 at a time, like so. Oh, my mistake here. Should be plus equal. Now you notice that we only display every second one. We have 34, then minus 243, then 1,000, and then we iterate past the end, so we just exit out of the for loop. So there we go. That's the way that you could use STD vectors to store numbers and be able to pull them off. And you're not restricted to using just integers. You can use floating point numbers, you can use characters, you can use whatever you like. You can create your own class and make this an STD vector of that specific class that you create. And all of these function calls will still allow you to work in the exact same way. Instead of adding in a number here, you just add in whatever your data type is. And when you're using your iterator, same thing. You'd still use star iterator, and then this will now return your new data type, whatever's typed in here. Now, if you've used C++ for any kind of string manipulation, you know how much of a pain it can be. Well, that's where STD strings come in handy. Let me show you how they work. Again, you need to go up to the top here, and inside the include, you need to include string. Down here, let's declare a STD string, like so, and let's just call it str. In standard C++, what you would do to replicate this is you would use something like this, char, and then you type in sz, I don't know, let's say name, you give it some size, 100. And when you wanted to allocate some string into here, maybe you'd use sprintf, and you'd say sz name, comma, and then type in whatever you want, mathematicnose.com. However, you cannot create another char, let's say sz name 2, with maybe memory of 100. You can't do things like this, name 2 is equal to name. If you try doing this, you're going to get a lot of problems. So instead of doing that, you need to do things like strcpy to do a string copy. So copying into sz name 2 from sz name, like so, and so on. And doing any sort of comparisons, you have to use a function called strcmp, and you do a comparison between one string and another. Well, you can avoid all of this headache if you just use STD strings. Let me demonstrate. Str equals www.mathematicnose.com. This is perfectly valid. The compiler will take this string of code and equate it to our STD string. Automatically, STD string will allocate enough memory to hold this for us. Again, we have a bunch of STD functions in here where we can get the size of our string. And again, you've got a bunch of other things which I recommend you going to check out inside MSDN to get the details on. But let me just demonstrate here some neat functionality. I've allocated some memory here that I've stored the string inside of. I can still go ahead and do things like this. My really long string goes here. Notice when I run this program, everything is fine. There is no crashing. I've taken this long string and I've copied it, well, I've placed it inside of STD string. STD string automatically knew that the current container was too small, so it enlarged it and was able to contain this larger string. And as a matter of fact, I can go in here and do things like this, where I actually shrink my container size. Well, I shrink the amount of space that I'm using inside of the container. And let me just demonstrate some numbers here for you. We'll type int I. So we'll do that after we have our first, well, let's do it up here as well. And then after each string allocation. Okay. So notice that initially our size is 0 and our length is 0. I copy over the string to have mathematicnose.com in there, and then when I take a look at the size is 19, and the length is 19. Then what I do is I change the string to be something larger, and then I check the size is now 31, and the length is 31, and then when I switch it down to be something shorter, the size is 3, and the length is 3 as well. So it looks like the size and length are automatically shifting and changing size to accommodate for exactly what I'm trying to store inside of this array. And all of that is working behind the scenes, so I don't really have to worry about it. One important thing to know about STD string is how to use it within standard C++ function calls. So for instance, if I wanted to do sprintf and I wanted to show what a string is currently containing, you can still use the %s operator. However, you can't just do this, str. If you try this, you'll notice that the program actually crashes. Yeah. Instead, what you want to do is use a specific function that's built into STD String. And the function that you want to use is .c_str. What this is going to do is it's going to return to us a pointer to a character string, which you can then use by this %s. So now when I run the program, you notice that my really long string goes here, and then, oh, I forgot to put a carriage return at the end. So we have our really long string, we have C++, and then that's it. So that's how you use STD strings. They're very handy whenever you're trying to do any sort of string manipulation. Okay, the last standard template library functionality that I wanted to show you is STD maps. And once again, to use the map, you need to do an include at the top here. So we'll include map. And to define a map, we're just going to type in std : map. And what a map is a way to construct a two-dimensional table. And this table is a table of associations. So imagine this like an Excel spreadsheet. You have two columns in this table. Column 1 will be of one data type, and column 2 will be of another data type. So you can make like a table that relates integers to, let's say, STD strings. Like so. Let me get rid of all this other stuff too. So what I've just done here is I've created a mapping from an integer to a string. And what you type in here is really up to you. You can make a mapping between any two items that you like. Now, when you create this mapping, what you're going to be doing is you're going to be saying, okay, this specific number really means this specific string. So as I'm adding items into this table, you're basically creating this lookup. And you create this for many number of reasons, usually when you're doing some sort of analysis of data that you want to simplify so that you can sort them, or maybe be able to reference a large number of items that are really not easily identifiable, so you give them all unique IDs. The IDs would be these integers, and then the actual items would be whatever's stored in here. And again, this could be like your own class, it could be strings, it could be floating point numbers, it could be anything in here. Alright, let me show you how to fill in this table. You do mtable, or whatever you've called it, and you need to do an insert. And by inserting, you're going to be inserting some data, but with the data that you're going to be inserting, you have to specify in terms of pairs. You want to pair up an integer with a string. So in here, you type in std make pair, and inside of the parameters of make pair, you need to specify an integer and a string. So here I'm going to make a pair between the number 1 and the string matic. So anytime I reference the number 1, I want to get back the string matic. And let's create a couple others. Let's make a pair 2, 3, and 4. And let's just type in some stuff here. Alright, now our table has 4 rows in it. And let's go in and do some analysis on this table. So we can do this. STD map. You've seen this already, where what I'm going to be doing is creating an iterator, and the iterator needs to be specific to the data type that I want to be searching. So because I've created an STD string here as my second parameter, and the first one is an integer, I need to specify that again. And here I'm going to do iterators to say that I want to create an iterator that's going to iterate through an STD map that contains integers and strings as the data inside of it. Now, using this iterator, I want to get mtable's value. So let's say I'm looking for whatever item number 2 is. If I do this, this find function is going to go through my table and look for the int value that is equal to 2. And it's going to return to us the location inside of this table as the iteration point. So once I have that, I can then print it to the screen. So we'll what I need to do is check to make sure that something was found, because it is possible that the iterator is not valid and it doesn't actually contain anything. And the way I do that is to check to see if my iterator's not equal to mtable.end. Now, if this is true, then that means I did find something, so I can just type in here %d is going to be the number that I'm looking for, and %s is the item that I found, and we'll put a carriage return at the end here. And the way that we get these values from our iterator is we go like this. We type in it for iterator, and then this iterator has two values, first and second. First is going to be this value, and second is going to be this value. So first is our integer, and then second is our string. Oh, and be careful here, because first is going to be returning an integer, so this is fine, but second is returning a STD string. And when you're using STD string, you can't just do %s by using STD string here. Remember, I told you just a second ago, you have to encase this and use C_string. And then we just close off the printf statement. And otherwise, if we are at the end, then we know we didn't find anything, so we're just going to print to the screen, not found. Alright, so when we run the program, we notice that 2 is equal to nose, because that's what we're looking for. And if I type in here 0, for instance, then it says not found, because there wasn't a pair here that started off with 0. If I change this guy to be 0, then I do a search, notice that 0 is equal to maps now, so I was able to find it. So that's the way you'd use STD maps. It's very handy whenever you want to create a lookup table between one value pair and another value pair. Alright, so if you have any specific questions on standard template library or how to use specific functionality, just send me an email or drop a line inside of the website's forum and I'll help you out.